Hello everyone, we are the group 39. Today, we will make a presentation to introduce our senior design. Our team members are Yunjia Wu and Xiang Li, and our advisor is William Wei. The topic of our senior design is human age detection based on neural network. This is an overview of our posters. Our posters is divided into 6 parts: present goals, Gantt charts, basic information of CNN models, training and testing process, workflow chart, final status. The age recognition through human face can be applied in many fields, such as business, social security, and transportation systems. Neural network technology has great advantages in the field of image recognition and age classification. We hope that the age recognition can be applied in Chinese public transportation systems. Public transportation systems in China, such as buses and subways, are half price for people under the age of 18 and free for the age over 60 in China. So we plan to design a neural network to recognize roughly age of human and divide them into child, adults, and the old, 3 age groups. It can identify the age of passenger when traveling on the public transportation, and it's intelligent. We aim to guarantee the accuracy is above 80%. We built a neural network structure based on the VGG16 structures, and we select a dataset, IMDb dataset, which contains 28 kilo human face images and with age labels. First, I introduce the basic information of CNN models. Our model is based on VGG16 constructions. It concludes 13 convolutional layers and 2 fully connected layers. The VGG16 structures is beneficial for ensure the classification accuracy, and the performance on ImageNet challenge dataset can be achieved when using a convolutional convolute structure with increased dips. Then I introduce our dataset. We use the IMDb dataset with 28 samples with age labels, and there are some typical pictures of human face in different age groups: youngs, adults, and the old. Then I introduce our Gantt chart. We show our Gantt chart for the whole school years. First, we spent about 2 months to determine the topic of our project, learn the basic knowledge of neural network, and we spent about 2 months to find dataset, processing the dataset and structures. In the first 2 months in this semester, we started to write code and train neural network. The next week, we will complete the project report. This video is a process to train the neural network. We will iterate 50 times for each training to ensure the accuracy can demand our needs. First, we want to divide them into 4 groups, and we found the accuracy is only about 60%. Here, you can see here the accuracy part is about 60%, and we found our accuracy it can't meet the requirement of 80 accuracy for age detection, so we give up this. And we found the problems. The problem is our dataset, because the dataset is a normally distributed models. There are a lot of data concentrated around 16 years old. So if we divide it into 4 groups, there are too many data distributed in distributed model. They are concentrated in 40 years old. So then we decide to divide it into three groups. This is a video. This is a video to train the neural network divided into three groups, and you can see here the accuracy is about 85%, and it meets the demand of our 80% goals. Next, let Yunjia to introduce the remaining parts.
Next is our training and testing process. We have classification 1 and classification 2. In classification 1, we divided age range into 4 classes: young, youth, prime of life, and old. And the number of training epoch is 50. And due to the data imbalance problem, because there are only 900 samples in young class while 16,000 samples in youth class, our training accuracy turns to be 38%, and the test accuracy turns to be 37.8%. So we have classification 2, which is our final version. That is divided age range into 3 classes: young, prime of life, and old. And the number of training epoch is 50. The training accuracy is 84.84%. The test accuracy is 84.82%. And the ratio of training dataset to test dataset is 9:1. And our test set is about 2.8 thousand samples. Next is our workflow chart. First, we have a connected dataset. We use the IMDb dataset, which contains 28,000 human face image with labels. Then we use the image data generator instructions to generate batches of tensor image data. Then we start to package data into different categories according to age labels. After pre-processing this data, we construct a neural network model. We choose VGG16 structure. Next, we initial and adjust these parameters. For example, we set learning rate at 0.003 and the keep rate in dropout is 0.5 to prevent overfitting. Then we train the data by training set and get final training accuracy. After satisfied with training accuracy, we then use the test set to test our model. We also encountered some difficulties. The biggest challenge is that the accuracy of our model is relatively low because of the data imbalance problem. We took two measures to improve the accuracy of our model. One is modify the range of age classification. Another is adjusting some parameters in our model. As mentioned previously, the first classification contains 4 categories. In the second classifications, we change it into 3 categories. In this way, the data imbalance problems can be solved, and the computation process is simplified. Then we also adjust some parameters such as learning rate as 0.003. The learning rate determines the step size at each iteration while moving towards a minimum of a loss function. Then we also set the dropout keep rate at 0.5. Dropout is an effective technologies to prevent overfitting. The term dropout refers to dropping out units, both hidden and visible in neural network. Finally, is our work accomplished and final status. School closures have not affected our progress. We initially planned to use the school computer to train the model to achieve an accuracy more than 80%. In fact, we can already achieve this requirement with personal equipment. Our senior design realizes age classifications through face recognition. All input face samples can be divided into 3 categories: young, prime of life, and old. Moreover, our model has achieved 84.82% accuracy with relatively fast training speed. That's all, thank you.